CSV files, Excel sheets, COBOL files, XML files, etc. So this is where all we can store the data, the databases, the files. Now there is the word data warehousing. Data warehousing is the process of extracting the data from usually varied. That means here I said a word heterogeneous. Heterogeneous meaning different types of databases. So data warehousing is a process of extracting the data from usually varied and heterogeneous source systems and integrating the data and transforming the data and loading it into a single target data warehouse database, so which will act as a common point of access for all the organizational reporting and analytical needs. So to keep it simple, data warehousing is nothing but we have so much of transactional data residing in the transactional databases, the OLTP databases. So data warehousing is a process where we extract the data from these transactional databases and load it into a single common data warehouse database. So let me show you. So this is what I was explaining in that statement. So the data warehousing process involves extracting the data from usually varied heterogeneous source systems and loading into the final target data warehouse database. So in the data warehousing project, we extract the data from usually varied heterogeneous systems. Usually varied means heterogeneous. So let's see what is heterogeneous here. The statement says that you may have to pull data from an Oracle database, you may have to pull data from a DB2 database, or you may have to pull the data from files as well. Wherever you pull the data from, if the databases are different, then we call them as heterogeneous source systems. Yeah. So heterogeneous meaning different. Like we have an Oracle database here, we have a DB2 database here, we have some files here. All these are heterogeneous. Homogeneous meaning same type. Heterogeneous meaning different. So data warehousing involves extracting the data from heterogeneous source systems and loading it to the final target data warehouse database. This will be used as a common point of access for all the end users for their reporting purposes. So end users will run their reports against the data warehouse database. Okay. So why is data warehousing project so popular? Why is data warehousing is so popular within the organization spheres? So let's say in this database we have some HCAT data, and in this database we have some sales data, and in files we have some other data. So if the end users want to report against different data like sales, HR, or maybe in this database we have some sales data. In this database we have some other sales data. In files we have some sales data. So end users want everything to be in one place, whether it is regardless of what source it is. So they want to store every data, every record in a single database, so that they don't have to run their reports against different databases. Instead, they can just run their reports against one database and fetch the data from that single database and show it to the end users and to the management people and all. So that's why the data residing in these different heterogeneous source systems will be extracted. Here E stands for extraction, and T stands for transformation, and L stands for load. So we extract the data from multiple heterogeneous subsystems. Transform the data meaning transforming meaning manipulating, changing as per our business requirements, and then loading it into the data warehouse database. So ETL process is involved in data warehouse. And not only ETL process, reporting is also involved, meaning end users run their reports against the data warehouse service. So to keep the things simple, I just gave a single statement here saying that data warehousing is the process of extracting the data from usually valid source systems, integrating the data, transforming data, and loading it into a single target data warehouse database. So if you want to say it in a single statement, like let's say in a one line, so it is simply the process of building the data warehouse database. So data warehousing is the process of building the data warehouse. Now let's see what is data warehouse. So data warehouse is subject oriented, integrated, time variant, and non-volatile collection of historical data. So this is a statement given by Bill Inman. Inman is known as the father of data warehouse. And I mean, there are two people, Bill Inman and another person is Rolf Kimball. So a few of the people say, okay, Rolf Kimball is the father of data warehouse. Few say Bill Inman is the father of data warehouse. But that doesn't matter for us. I mean, here this statement has been given by Bill Inman. So according to Bill Inman, he says that data warehouse is subject-oriented, integrated, time-variant, and non-volatile collection of historical data. So it is subject. Let us see what are these four characteristics that he is saying here. So this one also. So data warehouse is subject-oriented, integrated, time-variant, and non-volatile collection of historical data. So what does he mean by that statement? So subject-oriented. So subject-oriented is nothing but the data in the data warehouse is related to any specific subject like HR or finance or sales, etc. So here in the data warehouse, we might see a lot of data in the form of tables. And every record in a table will belong to any one subject. Like subjects here are like you can say different activities, business processes implemented by your organization. So in an organization there will be HR department, there will be finance, there will be sales process. So a lot of processes will be implemented in an organization to run the business mostly in an automated. So let's say you have a HR process implemented. So for that, you might use some software like ERP software like EBS, Oracle EBS, PeopleSoft, or SAP. So there are different systems, ERP systems available. So with the implementation of those ERPs and implementing the HR process based on the ERP module. So we might have a lot of data collected about every employee and the whole process of recruiting an employee and also till he leaves the organization. So the whole process, the records are maintained in a OLTP database. So as a data warehousing, when we implement a data warehousing project, we extract the data from those OLTP databases and load into the data warehouse database. So here, that's what I'm saying. In the data warehouse database, whatever the data you see will belong to any one particular subject, like HR, sales, marketing, any subject. And subject in the sense of business process here. Okay. So that means you don't see a single record which does not belong to any one subject. So we store the data in the data warehouse related to all the subjects of our organization. So that's why we call data warehouse as subject oriented, so that it actually stores the data about many subjects like HR, sales, finance, order management, etc. So that's why we call it as subject oriented and integrated. So data is integrated in the data warehouse to remove any data inconsistencies before loading into the data warehouse. So Integrated here meaning so we extract the data from multiple source systems here, right? The files, the OLTP databases and all. So maybe the data in these databases, for example, let's say here we have data, but the database is Oracle. Here we have some data, but the database is DB2. Here we have files. And then each database might support different data types. So, for example, here Oracle supports numbers, numerical data, characters, characteristic data. Maybe it will also support some integer sort of thing. Maybe DB2 might be handling few other different data types, and the data might be stored in this format in whatever the database supports. For example, DB2 supports few data types, so data will be stored in those data types only. And here Oracle supports different data types. The data in this Oracle database will be in those forms only. But by loading into the data warehouse from different databases, so the data will be inconsistent because of different data types here. But we have to remove those inconsistencies while loading into the data warehouse. And finally, the data will be stored in one single format. And this data warehouse is also a database. It could be either a Teradata database or an Oracle database or any database basically. But the thing is, here the data will be in different databases with different formats. But here the data will be in a single format, unique format. So that's what we are saying. Before loading the data into the data warehouse, any inconsistencies should be removed from the data. So that's why we call this data as integrated. So integrated meaning, so we integrate the data that is coming from different source systems with different data types, and we remove those data inconsistencies and load it into a single form. And that's called integrated. And now time variant. Time variant is like data entered into the data warehouse belongs to a specific time period. So let's see what it is. So here, time variant means for example, say you have a sales report, sales revenue report, and then I said, your total sales revenue is $1,000. So what does that mean? I mean, this is the report that I am showing you. So what does that mean? Yes. So basically, we don't know when this particular revenue has been generated, whether today or an hour back or a year back or 10 years back, or maybe the total revenue so far from the beginning of the company. So we don't know anything, right? So it doesn't make any sense. So similarly, data in the data warehouse, it belongs to a specific time period. For example, if I say, now the sales revenue is this much. Revenue is this much, and then year is 2011, let's say. So that means now you can say, for the year 2011, the total revenue is about $1,000. But then, if you don't give any time to any data here, that doesn't make any sense. So every record in data warehouse also belongs to a specific time. It may belong to today or yesterday or day before or year back or something. But then every record in data warehouse belongs to a specific time. Then only we can know, okay, so this sales happened on so and so date. So when I am counting the total sales revenue for a particular year, so all those records that belong to that year will be counted and say, okay, the total revenue for this year is this. But if you don't know the time of the particular record, I mean, when does it? It's as simple as this. You are hired, right? So let's say we are all hired in an organization. The total headcount is let's say 10. Even though we are 4 people here, the total headcount shows 10. But it could be that in the years, in total, the complete uh, the total headcount. But if I specifically say what is the total headcount hired in a specific year, let's say in 2012, then okay, in 2012 we hired 4 people. So like this, every record should belong to a specific time in the data warehouse. So that's why we call data warehouse as time variant. And then non-volatile. Data once entered into the data warehouse is never deleted. And new data is added, but data is never deleted. So this gives consistent picture to the business users. So it's as simple as this. Non-volatile meaning, so let's say today I have this is order, sales order. So sales order number and sales amount, or we can say amount and order date, etc. So we have a sales order number, let's say 123, and amount maybe some $400. Order date is let's say 1/1/2012. Okay. Now, as a process of data warehousing, that record, whatever record that is, whatever the record I'm showing here, sales record, that will be in this sales database, some OLTP database. And we pull the data into the data warehouse. Let's say today I pull that record. And the next day, there may be another sales record in the OLTP database, like 1, 2, 4 or something. And maybe some $300 that was booked on, let's say on some other date. Now, once I loaded the data into the data warehouse for the order number 123, and today again I'm loading the data that is extracting the data from the OLTP database, and then this time 124 is coming. Order number 124 is coming in. That will be loaded. But that doesn't mean we will remove the previously loaded 123, order number 123. Right? So if you remove this, then the total revenue still shows, okay, total amount that you got is only 300. It doesn't give any consistent picture. And tomorrow, on the day one, we were showing 1, 2, 3, 400. This one. So total revenue on yesterday was like $400, and after one day it shows $300, and the order number is 124, and earlier it was 123. So that will give a very confusing picture. Right? So to give a consistent picture, once data entered into the data warehouse is never deleted. If required, let's say the order number, for this order number, the amount was not 400, actually it was 700. And if required, we will also update the data warehouse record. So yesterday when we are loading, the order number 123 has an amount of 400, so we loaded 400. So today the order value has been changed to 700, so we will also change it to 700. But we will not delete it. So that's what the statement is here. Data once entered into the data warehouse is never deleted. New data is added, but data is never deleted. So once we enter the data, any single record into the data warehouse, it is not supposed to be deleted. Even though now, let's say after a couple of days this order got cancelled, order 1 to 3 got cancelled. So we should not, even though it got cancelled, that doesn't mean that we should remove it from data warehouse. Instead, we will say, okay, this order has been cancelled. We update the status of the order in the data warehouse to cancel. But we should not, okay, since this has been cancelled by the customer, we should delete it. No, we should not. Because management might want to know how many cancelled orders are there, or how many orders have been cancelled after like 4 days or so. So they want to analyze the data, every single record. So that's why we call data warehouse as non-volatile, because we never delete the data once entered into the data warehouse. So data mart. Data mart is a subset of data warehouse. When I said, okay, data warehouse is subject oriented, so it will have data about many subjects like HR, finance, or sales or something. So that means in a data warehouse, we will be having data belonging to many different subjects. But in a data mart is just a subset of data warehouse. That means it will be having data about any one specific subject like HR, finance, or sales or something. Any one specific subject. So that's why data marts are called the subsets of data warehouse. So usually data marts can also be called the access layers of data warehouse environment. We'll understand this statement later in the fundamentals. But then for now, let us go with this statement. Data mart is a subset of data warehouse. It will just talk about any specific subject. Like if I say HR data mart, and then in that HR data mart, you will be having the data related to only HR. So data mart will be having data about any one specific subject, whereas data warehouse can have data about multiple subjects. That means technically in a data mart we'll be having very less number of tables with only those belonging to that particular subject. So let's say if I build a data mart for HR, I'll be having like say 20 tables or 30 tables that store the information of HR subject, like the employees, the jobs, departments, etc. And similarly, if I say, okay, I built a sales data mart, then I'll be having in like, let's say around 20 to 30 tables that can store the sales data like orders, products, sales, revenue, customers, etc. So data marts handle a single subject, whereas data warehouse will have data about multiple subjects. So I'm going to explain the different types of different architectures. The one that you're seeing here is the latest one, but I'll try to explain you the different architectures of data warehousing. So there are two traditional data warehouse architectures. In fact, I think there is one for traditional also. Yeah. So there are actually traditional architectures, and I will also explain about the latest data warehouse architecture. The one that you're looking at here is called a bottom-up approach for building a data warehouse. So in this data warehouse, this approach is actually proposed by Rolf Kimball. Rolf Kimball, like I said, is also considered as one of the father of data warehousing. So in the bottom-up approach, this approach is called bottom-up approach. In this, the data from these transactional data, databases, we extract it and transform and load it into a staging area first. So data will be extracted from the OLTP databases or files and loaded into staging area. Staging area is nothing but again a temporary storage area. So first data will be loaded into the staging area. It is also a database. Staging area is not like any other hard disk or something. It is also a database with tables in it. So first data will be extracted from these transactional databases and loaded into staging database. And from there, the data will be loaded into the respective data marts. So let's say we have different data marts like HR, finance, sales, etc. So we will be having individual data marts. We'll be building the individual data marts first. So like I was explaining, data mart is it handles data about a specific subject. So data will be stored in these data marts. In the bottom-up approach, we first build the data marts and then the data warehouse. EDW stands for Enterprise Data Warehouse. So once we build these individual data marts, then finally we build one single enterprise data warehouse database. So the all symbol approach suggests that you first build the individual data mart and then the data warehouse. And that's all. Then this approach is called bottom-up approach of building a data warehouse. So if somebody asks you, okay, what is architecture of data warehouse, you can say in a data warehouse we will have source systems, staging area, data marts, and data warehouse. And then there is a reporting interface called OLAP interface. So using this interface, end users can create their reports or log in and check their reports, run their reports against the data warehouse database. So again, this OLAP interface is again built by us, but then it will be accessible by the end users as well. So in a bottom-up approach, the only thing is you first build the data mart, small individual data mart, and then finally club all these data from all these different data marts and load it into a single. Now there is another approach called top-down approach, and this was proposed by Bill Inmon, in which the data from the OLTP databases, the files or OLTP databases is first extracted and loaded into the staging area, and from directly it will be loaded into the data warehouse, and then from data warehouse, from the enterprise data warehouse, the data will be divided into data marts. Okay, so here in this process, you are first building the data warehouse and then loading the individual data marts. And these individual data marts will act as a layer for the access layer for the reporting. So reports, in the earlier approach, reports run against the data warehouse, and in this approach, reports run against data marts. So data marts will be acting as the access layer. So in this top-down approach, first we build the data warehouse and then the data marts. Whereas in the previous approach, first the data marts were built and then the data warehouse. So these are the two different approaches proposed by two different people for building a data warehouse. Any questions on this? Okay. So if you don't have any questions, yeah. Any questions?
Which is the most efficient of these two?
I would say the one that you're looking at right now, the bottom up, because if you are supposed to build a big data warehouse first, then you have to consider a lot of things actually. So you have to think about the whole different subjects involved, and you have to you have to build a big data model. I mean, how to store the data in the data warehouse. That data belongs to say different subjects and all. So planning for a bigger thing initially will be tough because you have to consider a lot of things. For example, you might want to pull the data from different OLTP databases. So you have to think about handling all the different data types and all. And that will be a very big headache initially to plan in a bigger scale. Instead, in a bottom-up approach, you can plan for small data marts, and then once the data is there in these data marts consistently, then you can build a data warehouse. So most of the organization used to follow this approach, bottom-up approach, because top-down approach is relatively tough in terms of designing, in terms of development.
Thank you, sir.
No problem. And nowadays, the architecture has changed like this. So this is the latest architecture that you can expect in an organization. So, like, and this is especially for those people who are interested in BAS. So this is going to be this. So, and the transactional databases are common and the files and all. And we use the ETL process, the extraction, transformation, and load process to extract the data from multiple different data sources and load into the data warehouse. And within the data warehouse, there will be different kinds of tables. The staging tables, the warehouse tables, the summary tables, and metadata and the application tables. So here, earlier, the staging tables were in the staging area. I mean, you have a separate database, separate staging area for storing the data in the staging. To store the data that is coming from OLTP, we have a separate staging area. But now, in the latest approach, those staging tables that were earlier used to be in a staging area, now we don't have any separate staging area. Instead, all the tables from the staging area are moved to the data warehouse. So all the tables that are earlier used to be in the staging tables are now a part of the data warehouse database itself. So within a data warehouse only, we have the staging tables. We have the dimensions and facts. These are the main warehouse tables. And then we have summary tables, aggregate tables. These also belong to the warehouse. And then there are some metadata and application tables. So if you're implementing a data warehousing project, you might want to use many different tools. For example, Informatica for the ETL process, DAC for a scheduling process, and OBA for the reporting process. So, and when you install these different software, they might create their own application tables, and those tables can also be part of data warehouse. I mean, it doesn't have anything to do with reporting, or it doesn't mean that we show the data of the application tables to the end users. But it's just that whenever you install some software, it might also create some of its application tables that are required for the tool to function. So those tables are also part of data warehouse. Now, the scenario has changed like this. From the OLTP databases and files, data will be first loaded into the staging table. And from staging tables, the data will go into the dimensions and facts. Those are also tables. And then from the dimensions and facts, data will be going into what you call aggregate tables or summary tables. So this is how the data warehouse is managed these days. And to load the data from OLTP databases and files into the staging tables, we need a ETL process. And similarly, to load the data from staging tables to dimensions and facts, also we need ETL process. And same is the case with while loading from dimensions and facts to aggregate summary tables, we need a ETL process. But then the beauty is you don't have too many databases to maintain here. So if you look at this, or this approach, there are so many databases involved here. So now the beauty is that we don't have to maintain those many databases. Everything is in a single data warehouse database, and that makes our job easy. And the data in the data warehouse is loaded. We have a OLAP interface. In this, there will be usually three layers, like the physical layer, the business layer, and the presentation layer. Especially for those who are working in OBIE or who want to work in OBIE, should know this. In the OLAP layer, you have three layers: physical, business, and presentation. So the presentation layer is what is accessible to the end users. I mean, so they can't see what is there in the physical layer. They can't see what is there in the business layer. They can see, okay, what is there in the presentation layer. Presentation layer is accessible to the end users. And while presenting the data, even though the data of HR, the tables that belong to HR, finance, or sales, everything will be in the data warehouse only, in the form of dimensions and facts. But then while presenting it to the end user, we'll divide them, okay. These out of 100 tables in the data warehouse, these 30 tables belong to HR, these 20 tables belong to finance, and these 30 tables belong to sales, so on and so forth. So even though all those tables are in a single data warehouse database, while presenting it to the end user, we specifically show him that these tables belong to HR, these table belongs to finance, these table belong to sales, etc. So this way, in a way, we are dividing it. After the data is loaded into the data warehouse, we are dividing it into individual subjects. And that's why we call them as virtual data maps. The reason is, if you look at the top-down approach, we first load the data into data warehouse, and then divide it into different data maps. And those data maps are accessible by the end users. Similarly, in the latest approach, we will be extracting the data from the OLTP databases and loading into the data warehouse. And while finally presenting to the end users, we are dividing the data and the table into different subjects and presenting it to the end user. In a way, we are building some virtual data maps here, meaning those are not really different databases, but just while presenting it to the end user, we are virtually presenting them as data maps. So any one specific subject here deals about only one specific subject. Like HR subject area will show only HR related data. Again, those HR tables will be here in the data warehouse, and finance will also be in the data warehouse. Everything will be in the data warehouse. But then while presenting it to the end user, we divide them and show them, separate them and show them. So this is the latest architecture, especially you can see this kind of architecture in BAS, very popular business intelligence application software. So this is the architecture that you can see. Any questions on this? And why I specifically said Informatica here. BAS uses Informatica, DAC and OBIE. But then here it need not be necessarily Informatica only. So ETL tool can be anything. ETL tool can be data stage, or it can be what you call Ebenshio. There are different variety of ETL tools available out there in the market. But I was just showing you the most popular ETL tool. And DAC is a scheduling tool. So whatever the ETLs that we develop in Informatica, those ETLs will be scheduled using a tool called DAC. And OBIE is for creating the OLAP layer and reports and dashboards. So this is the latest architecture, rather. One second. Any questions? think we will stop it here for today. And tomorrow, yeah, thank you. So tomorrow, please be on time, like exactly by 6:30 a.m. IST. So we have so many other topics to discuss. So first couple of classes will be on the fundamentals. It is not necessary that you by heart these things. It's good you understand them. At least you know that you have some points like this. And read through this document. And then once we are done with this fundamentals, then we will start with Informatica. So maybe another 2 more days that I want to cover these fundamentals, and maybe after that we will start with Informatica. Okay, so we'll stop it here for today. If you don't have any questions regarding anything, not only the subject, if you have any concerns about the links and all. See, as far as the WebEx link is concerned, you will get one fresh link every day. So that will be emailed to you. So the old links may not work because those meetings are already completed. So you will have to click on the latest link that I sent.